Mysterious radio signal is coming from inside our galaxy, scientists announce. Mysterious, intense blasts of radio energy have been detected from within our own galaxy, astronomers have said. Fast radio bursts, or FRBs, last only a fraction of a second but can be 100 million times more powerful than the Sun. Despite their intensity, their origin remains largely unknown. Now astronomers have been able to observe a fast radio burst in our own Milky Way, for the first ever time. As well as being closer than any FRB ever detected before, they could finally help solve the mystery of where they come from. Scientists have had trouble tracking down the origin of such blasts because they are so short, unpredictable and originate far away. It is clear that they must be formed in some of the most extreme conditions possible in the universe, with suggested explanations including everything from dying stars to alien technology. The bursts of radio energy appear to have come from a manta, or a star with a very powerful magnetic field. The scientists who discovered the new FRBs said they were able to confirm that the blast would look like the other, more distant FRBs if it was observed from outside of our own galaxy, suggesting that at least some of the other blasts could be formed by similar objects elsewhere too. There's this great mystery as to what would produce these great outbursts of energy, which until now we've seen coming from halfway across the universe, said Kiyoshi Masui, assistant professor of physics at MIT, who led the team's analysis of the FRB's brightness. This is the first time we've been able to tie one of these exotic fast radio bursts to a single astrophysical object. The detection began on April 27, when researchers using two space telescopes picked up multiple X-ray and gamma-ray emissions coming from a manta at the other end of our galaxy. The next day, researchers used two North American telescopes to observe that patch of sky, and picked up the blast that came to be known as FRB 200,428. As well as being the first FRB from the Milky Way and the first to be associated with a manta, the blast is the first to send out emissions other than radio waves. The research is described in 3 papers published in the journal Nature Today. It relied on data taken from telescopes around the world, with an international team of scientists using observations taken from equipment in Canada, the US, China and space. FRBs were first discovered in 2007, immediately prompting a flurry of speculation on what could be able to cause such intense blasts of energy. Mantas have emerged as the most likely candidate, especially given theoretical work that suggests their magnetic fields could work like engines, driving the powerful blasts. To test that, astronomers have attempted to place the origin of the bursts within as small parts of the sky as possible. In theory, that should allow them to associate them with known objects in space, and look for associations between the bursts of radio energy and other astronomical phenomena. The new study is the first to do that work and to provide evidence linking the FRBs with mantas. At the very least, that could be a valuable clue to the origin of at least some of those FRBs. We calculated that such an intense burst coming from another galaxy would be indistinguishable from some fast radio bursts, so this really gives weight to the theory suggesting that mantas could be behind at least some FRBs, said Pragya Chawla, one of the co-authors on the study and a senior PhD student in the physics department at McGill. The new findings may still not explain all of the known FRBs given the large gaps in energetics and activity between the brightest and most active FRB sources and what is observed for mantas. Perhaps younger, more energetic and active mantas are needed to explain all FRB observations, said Paul Scholes, from the Dunlap Institute of Astronomy and Astrophysics at the University of Toronto. If the FRB can be proven to have come from a manta, many mysteries still remain. Astronomers will need to look for the mechanism that allows the manta to power an FRB, looking for instance to understand how it could send out such bright, unusual bursts of energy and X-ray emissions at the same time.